For this video, we're going to talk about the standard normal curve. And when we're talking about the standard normal curve, what we're talking about is just that normal curve that is normally distributed. And so we're also going to be talking about probability density curves. And what these are for us to look at the area underneath these normal curves. So we're looking at how much area is underneath this curve from this point to the left, for instance. The curve is used to describe the distribution of a continuous random variable. Remember, we've already discussed discrete random variables, and so these are going to be used to discuss continuous random variables. It tells what proportion of the population falls within a given variable. It can be here, or we can have in between two numbers, such as if I want to look at the proportion of the values that fall between these two lines, we can also find that. Now the area under the entire curve is equal to 1. Remember, all probabilities add up to 1, so the area underneath this entire curve also adds up to 1. And the area under a curve between two values, a and b, have a couple of different interpretations. So let's just say that this is a and this is b. So the proportion of the populations whose values are between a and b, or the probability that a randomly selected individual will have a value between a and b. These are the two interpretations that we can look at when we're talking about the probability density curve. Now then, the most common probability density curve that we look at is the normal distribution curve. Again, this is that normal one that we were talking about, and it specifically has that one mode, which is in the center, and it is symmetric around the mode. So here's going to be our mode in the center, and it's going to be symmetric, meaning we can overlap it, and this side is going to be equivalent to this side. Our mean and our median are going to be equal to our mode, so that means that our mean, our median, and our mode are all going to be here in the center of our normal distribution. And this normal distribution also follows that empirical rule. Recall that the empirical rule stated that 65% of the data fell within one standard deviation of the mean. So if this is the mean, and we do the mean minus one standard deviation, and the mean plus one standard deviation, that is 68% of the data between these two values. If I do two standard deviations away, so the mean minus two standard deviations, and the mean plus two standard deviations, that is going to be 95% of the data for this whole box here. Okay? And previously we said that 3 standard deviations was going to be almost all of it, and for our case here, it is almost all of it. It's 99.7% of it. That is, if we add 3 standard deviations, or if we subtract 3 standard deviations from the mean. So again, this is still following that empirical rule that we have looked at previously. And so when we're looking at this, a normal distribution can have any mean and any positive standard deviation. What we just usually do is we want to normalize it. And what we want to do where we normalize it is we use that z-score. Recall that the z-scores are usually our value minus our mean divided by our standard deviation. We figured these before. That was our z-value. Well, we want to use what is called the standard normal distribution. The standard normal distribution. And with the standard normal distribution, what that is saying that we have a mean equal to 0, and our standard deviation is 1. So this is going to be a positive 1, a positive 2, positive 3, negative 1, negative 2, and negative 3. So we've gone out those 3 standard deviations that we normally do. And what we're going to do is once we normalize any normal distribution, then we can compare and do other such things. But we're going to use the standard normal distribution to find the area underneath a curve. So for example, if I want to find the area, under the standard normal, curve to the left of z equaling 0.74. Okay, what that means is I've got my standard normal here. 0 is here. 0.74 is here. And I want everything to the left of it. So that means I'm going to shade in to the left. And we always want to draw the picture so we know what side, where we're looking, things of that nature. And so I'm looking at this to the left. Well, in order for me to find the area, what we're going to do is we're going to look at what we call the standard normal table. And so the standard normal table, if you look here at the top of it, it tells you that the area that the table is giving you is always to the left of the z value. And it is going to show you the z value. And recall that when we were calculating z-scores before, we always rounded to 2 decimal places. And so the whole number and the first decimal place are here in this first column. The second decimal place is along the top column, or top row. And so when we're looking through this, you'll notice that there are 2 pages to the normal distribution table. There is one with the z's being negative, and then there is one with the z's being positive. So these z values are where they're on the left side of the mean. These are where on the right side of the mean. And you'll also notice with the numbers, these are all with a probability or area of 0.5 or less, because they are half the value or half the curve or less. These are all 0.5 or larger. That's because they all have this half plus some more. And so when we're looking up these values, like what we want is 0.74, and so we're going to look at the 0.7 here in this row, 0.7, and the 4 is here, okay? And we want to see where they intersect. So the area to the left of z equaling 0.74, that area, or the probability that 0 is less than 0.74, is equal to 0.7704. What that means is that it has taken up more than half of the table plus some extra. Okay, so let's look at another possibility, and that is we want to find the area under the standard normal curve to the left of z equaling negative 2.16. Okay, so I'm going to draw my curve, and here's 0, so a negative is going to be over here, negative 2.16, and it says to the left, so I'm still going to shade to the left. So then I'm going to go and find my z value, and let's see here. That is going to be negative 2.16. So I'm going to come to the negative z's, 2.1. So 2.1 and 6. And so it's going to be 0.0154. So the probability that z is less than negative 2.16 is equal to 0.0154. And now what we're going to do is we want to find the area under the curve to the right. So we want to find the area under the curve to the right of z equaling 0.53. So here's my curve, here's 0, and 0.53 is over here, and I want to the right. Okay, well, remember, our table gives us to the left. So there's two different ways we can work this, okay? We can look up this left side, which will give us this portion, and recall that the entire chart is equal to 1. So this is going to be 1 minus the left side. Okay. Or you can also remember that this graph is symmetric. So this portion is the exact same as if I were to look up a negative 0.53 and over here. Okay? Because this side would be the same as this. You can do it either way. I'll show you that they both give you the same answer. So I'm looking at 0.53. So 0.5 and a 3 gives me 0.7019. Okay? So that means that this right here is 0.7019. So that means that this area is going to be 1 minus my 0.71. Left out a 0 there. I'm going to go back and put in that extra 0. So 0.7019. If I subtract those, that gives me 0.2981. And what I was saying was this right here is the exact same thing as looking up the opposite sign. If I want to the right, I can also look up the opposite sign. So I'm looking at 0.53 So if I look up a negative 0.53, so here's a negative 0.5 and 3.2981. Oh look, that's a 0.2981. Same thing as what I got over here. Either way, I got that the probability that z greater than 0.53 is equal to 0.2981. You can do it either way. You just have to remember that if you're looking for the right side, you either have to subtract from 1 or you have to look up the opposite sign. Does not matter which one you want to do. You can do it either way. Now let's look at another example where we have to look up and try to find the in-between. Okay? So what I want to do is find the area between z equaling a negative 1.28 and z equaling 1.36. So here, what we're going to do is I'm going to come here, draw my curve. Here's 0. So a negative 1.28, let me put that decimal in the correct place, negative 1.28, that is going to be right here, and a 1.36 is right here. I want the area between them, okay? But remember that the table gives me to the left. So the table is going to give me this, and the table is going to give me this. I just want this portion. So that means what I'm going to have to do is I'll actually have to subtract it. So let's look up 1.36. So 1.3 and a 6 gives me 0.9130. So that's 0.9131. Then I'm going to look up a negative 1.28. A negative 1.28, so a negative 1.2 and an 8. Okay, so I've got that, which is 0.1003. So that's going to be a 0.1003. And again, these give me all to the left. So what I really want is for the probability of z being between a negative 1.28 and a 1.36, I want 0.9131 minus the 0.1003, which is 0.8128. So anytime they're in between, you have to look them both up and then subtract the probabilities. Do not actually subtract the z-scores. Subtract the probabilities after you have looked them up. Okay? Now, I want to look at one other thing, and that is find the z-score for which the area to its left is 0.13. So this time I'm given the area and I want to find the z-score. So if I draw my curve, I know that this is going to be 0. So if it's 0.13, I know that it's going to be somewhere over here because it's less than half. So this is 0.13. And I'm going to put 2 zeros on the back end because our z-table always gives us area in 4 decimal places. I need to find the z that goes along with that. So what we're going to do is we are going to look at the z-table, and we want to look up 0.13. Remember that area is the center of the table, okay? Well, these are the positive values of the z-score, which are 0.5 and above. So I've got to come up here to the negative z-scores, and I want to look down through here to find 0.13. So these are all 0.0s. Here's a 0.1, here's a 0.13. I want to get as close to 0.13 as possible. Okay, and right here we go. Let me get that back on my screen. So right here I have 0.1314 and 0.1292. I cannot find 0.13 exactly. So what I do is I go to whichever one is the closest. So if you notice, this one is 14 points away, where this one is only 8 points away. Okay, and so you go to the one that is the closest. And so it's this one. And so I'm going to follow it out and find its z-score. So that's a negative 1.1, and I'm going to follow it all the way up. And if you can see underneath there, that's a negative 1.13. So that's my z. Again, whenever you are given the area or given the probability, you look for it in the center and follow it outward. Practice finding some of these and let me know if you have any questions.